So this is another problem. Uh, so we have to compute the most probable distance of the electron in the ground state of a hydrogenic atom. What is the radial probability density at that distance? So the solution is, so we have to calculate the radial probability density. So radial probability density is computed using this formula. So PNL, principal quantum number, and orbital quantum number. So the radial probability density depends only on R, which is equal to simply R square and modulus of RNL of R square. Okay, and this is so we can calculate for the ground state. It is given in the question. So therefore, for the ground state, we know that R n is equal to 1, L is equal to 0, R10 of R is equal to, so 2 times Z by A naught the whole power 3 by 2 and exponential of minus ZR by A naught, where A naught is the Bohr radius, right? Okay. Now let us substitute this one here. P10 of R, because this is for the ground state, the radial probability density now becomes R square times. So this is R10 star into R10, and therefore it is simply 4 times Z by A naught the whole cube, and this is e power exponential power minus 2Z R divided by A naught. So this is the radial probability density, and therefore this is equal to 4Z cube by A naught cube R square into exponential of minus 2Z R divided by A naught. Now when the radial, see, it is given that the radial probability density for this, the most probable distance is asked. So we have to calculate the either the maximum or minimum. So we have to calculate the first derivative must be equal to 0, right? So the most probable density is the probability, that is radial probability density, has to be maximum here. So will be maximum, that is, so for either maximum or minima, the radial whatever we have function for maximum minima, it has, the first derivative must be equal to 0, right? So P10 of R by dr, this is equal to it must be equal to 0. Now let us calculate the derivative of this. So what is P10? So P10 of R, which is equal to 4, okay, and this is 4Z cube by A naught cube e exponential of minus 2Z by A naught R. So dP10 of R divided by dr is equal to, so there is an R square here, okay. So let us now calculate. So these are constant, so we need not to worry about this. So we have to use product rule because there is an R here, there is an R here. So here it is an R square. Therefore when I take the derivative, 4Z cube by A naught cube, so 2R exponential of minus 2Z by A naught R. Now this part I can take derivative. When I take the derivative, the first term we can keep it as a constant. So just using the product rule here, okay, and this is R square. So exponential derivative is simply same exponential 2Z by A naught Z into r into the derivative of r gives you the coefficient. Okay, now we can pull out the common terms. Okay, these are also common, so we can pull out the common terms outside so that we can easily simplify this. 4z cube by a naught cube exponential of minus 2z by a naught r, so the remaining term is 2r minus, so this term will become minus 2z by a naught r square, and that is equal to 0 because the first derivative has to become 0, right? So this term cannot be 0, these are all constant, so this cannot be 0, non-zero, they are non-zero constant. And the exponential term, this term is also not 0. If this becomes 0, the entire the probability density will become, the radial probability density will become 0. So therefore these two terms cannot be 0. So that this will become 0 if this bracket term vanishes. So this implies 2r minus 2z by a naught r square is equal to 0. So we can pull out 2r outside. 1 minus z by a naught r is equal to 0. Okay, so therefore for this choice of r, when I put r is equal to this a naught by z, so what will happen when I put r is equal to a naught by z? So this part will become, the combining these two parts, it will become 1. So 1 minus 1, it becomes 0. So when r is equal to a naught by z, this entire term becomes 0. Hence, so r is equal to a naught by z is the required most probable distance. Okay, so therefore the maximum value of the radial probability density, okay, is just by substituting this p1 of 0 r, the r value whatever we obtained, just substitute, that gives the maximum value of the radial probability density. So 4z cube by a naught cube r square, right? Now r is nothing but a naught by z the whole square, and exponential of minus 2z by a naught, instead of r you substitute a naught by z. So these two gets cancelled, these two gets cancelled. Now this is 4z cube a naught square divided by a naught cube z square e exponential of minus 2. Therefore this is equal to so one term survives for a naught, and here also one term in the numerator survive, 4z by a naught exponential of minus 2, and this is the maximum value of the radial probability density. Okay, thanks for watching this video.